Hi everyone. In today's video, we will know about elastic container services. So what is elastic container services, why it's important, what are the features, how it works. So let's move to agenda and see one by one. In this video, we will learn what is elastic container services, why it's important, key features and architecture, how it works, and ECR versus other orchestration tools. So let's see one by one. What is elastic container services? It's a fully managed services and we can easily allowing to deploy, manage and scale containerized applications, and we can run containers without needing any manage or provision instances, and also developers to focus building and deploying the applications. So let's see the definition. Amazon Elastic Container Services is a fully managed services that enables user to run Docker-based applications in the containers across a cluster of EC2 instances. ECS simplifies containers orchestrations, allowing you to deploy, manage, and scale containerized application efficiently. So ECS is a fully managed services, and we can run the Docker-based applications in the container in the EC2 instances. We can easily simplify the container orchestrations, and it helps to allowing you to deploy, manage and scale the containerized application efficiently. And the services supports multiple launch types, including the AWS Fargate launch type, which abstract the underlying EC2 infrastructure, enabling you to run containers without needing to manage or provision the EC2 instances. So the services, it supports multiple types, including the AWS Fargate launch type, and also we can underline the EC2 infrastructure. We can run containers without needing to manage or provision in the EC2 instances, and the developers to focus building and deploying the applications, while AWS handles the cluster management and resource provision. So in the ECS, developers only focus on building and deploying the applications. The AWS itself handles the cluster management, resources and provisioning. So this is what is AWS ECS. So let's see why it's important. Why AWS is ECS? Is a powerful choice for container orchestration because it simplifies the deployment, scaling and management applications while leveraging the robust AWS ecosystem. So because ECS is a powerful choice and it simplifies deployment, scaling and management applications in the ecosystem. And it offers seamless integration with AWS services like IAM for secure access, CloudWatch for monitoring, and Elastic load balancing for topic distributions, making it an ideal platform for running the scalable and highly available applications. ECS is a seamless integration like IAM for secure access or CloudWatch for monitoring and load balancing for traffic distributions, like that. It's a seamless integration, and you can scalable and highly available application platform. With ECS, user can choose between the serverless Fargate options, which eliminates the needs to manage infrastructure, and EC2 options for greater control over compute resources. So with the ECS, users can choose between the serverless options, and also it helps to eliminate need to manage infrastructure and EC2 options for the control over the compute resources. So that's why ECS is important. The next is features of ECS. The features are, remove the need for user to manage their CPU type cluster, the management system by interacting with the AWS Fargate, and it allows the seamless deployment of container based applications. This can be scheduled or done by the simple API calls. Means in the ECS features it removes the need of users to manage the cluster, and it allows the seamless deployment of container based applications, and ECS is take care of management and monitoring the application cluster, and it's a region specific. This means cluster can only scale up down in a single region. So in the ECS region, in the single region, we can start or shut up the container instance, and the clusters are dynamically scalable. These are all the features of ECS. So we can easily startup and shutdown in same region, and dynamically scalable, and take care for the management application cluster, and it can schedule the simple API calls. We can easily remove the users to manage their CPI type clusters. So the next is Amazon ECS terminologies and components. So Amazon Elastic Container Services is a managed services for its deploying, managing, and scaling the containers. Is a quick look at the key components. The terminologies and components are divided into three parts. One is provisioning, controller, and capacity options. In the controller contain the ECS scheduler, that is Amazon ECS scheduler. In the provisioning, it has a Amazon Web Services command line interface, and the management console, and web services cloud developer kit, and also it can work otherwise in the software developer kit. We can use the CLI or console or cloud developer kit or SDK. In the capacity option, you can use the Amazon EC2 instance and the web services target or on-premises compute. So based on the ECS scheduler, we can use the terminologies and the components using the provisioning and capacities options. The next is advantages of ECS. The advantages are scalability, high availability, cost effective, integration, and security. So let's see one by one. The scalability. ECS automatically scales your application based on demand, allowing you to easily handle changes in the traffic or workload. The next is high availability. ECS provides built-in availability and fault tolerance, ensuring that your application are always up and running. The next is cost effective. ECS enables you to optimize your infrastructure cost by scaling resources based on the demand and only paying for what you use. So in the cost effective, we can pay only what we are using. The next is integration. ECS integrates with other AWS services such as Amazon ECR, AWS Fargate, and Amazon CloudWatch and AWS IAM. You can integrate with in the previous video we will learn ECR, how it works, and the features and advantages. So the next is security. ECS provides a secure environment to run your applications with features such as IAM, role for task, VPC, isolations, and encryption at the rest. So let's move to the next slide. That is how ECS work. Amazon Elastic Container Services is a fully managed services which provided by AWS. It is mainly used to deploy containers that are Docker based, by which you scale up and down depending on the traffic you are going to get, and this container will run inside the Amazon Elastic Cloud instances. It works based on the container, Docker, cluster, and container instances. So we'll see how it works. In the container is a package that holds the application and everything, dependencies, libraries, etc. So the application requires to run. The container are independent of the underlying operating systems, and hence container applications are fairly portable, flexible, and scalable. This ensures the applications will run always as expected, irrespective of the system and environment which is the container run. So it's container. The ECS is a container. In the container is a package of container. All the everything dependencies, libraries, all are containing in a container. So it can be application can requires to run. Containers are independent for underlying the operating systems, and it's a flexible and scalable. We can easily run always as the expected irrespective of a system. The next is Docker. Docker is a software that facilitates and automates the installation and deployment application inside the container. So using the Docker, we can install and automates the facilitate software deployment inside the Linux container. The next is cluster. Cluster is a logic group of EC2 instances running a single application. Cluster helps to run the single application. The next is container instances. So each EC2 is an ECS cluster is called as a container instance. This is how the ECS work. The next is use cases of the AWS ECS. So the use cases are highlight practical scenarios, include step-by-step insights, real-world use case examples, engage with storytelling, and future potential with the ECS. So highlight practical scenario. So start by identifying the specific relatable scenarios like managing the high traffic website, processing real-time data or microservices, architecture for startups. It shares the relatable examples to illustrate the how ECS enhances scalability, reliability, and the cost efficiency, and include step-by-step insights. So rather than technical deep dive, it offer a journey like approach for instances how to deploy and scale the application seamlessly with the Amazon ECS, and also where you can guide regards from the step to monitoring. The next is real world use case example. So it showcases the industry or business that commonly use ECS and how it help addresses their specific needs like handling the seasonal traffic spikes or ensuring the seamless deployment in the fast changing environments. The next is engage with the storytelling. These are all the real life scenarios of it work in the ECS. So it framed the content as a narrative about a company or a team needing to improve their application performance and cost management. So it walked through the decision to use the ECS, the challenges they faced, and how ECS become a game changer. So the next is future potential with the ECS. So the further implications like integration ECS with other AWS services for AI or data analytics, and how this could drive the initiative in the specific industries. So these are the use case of the AWS ECS. The next is ECS pricing. So the ECS pricing are in three ways. One is forget mode, another one is EC2 mode, and the last one is savings tips. So in the forget mode, pay for CPU and memory used by the task. So we are using the memories and CPUs for the task. So we won't, in the forget mode, we only pay for the CPU and memory so used by task while we are running the task and playing some like that. In that time we only pay for that task only. The next is EC2 mode. So in the EC2 mode, we only pay for EC2 instance and other additional services like storage. So we are using our instances or S3 buckets like that. So that only for the storage services we only pay. The next is saving tips. So in the saving tips, we can use spot instance for the cost efficiency. So we can only use the instances for the cost efficiency. These are all the ECS pricing. So we can pay in the three ways, one for the forget mode, another one for the ECT mode, and the savings tips. So these are all the theory part of the ECS elastic container services, how it works, advantages, use cases, why it's important. So let's move to the demo and see how it works. So here we will see how to easier elastic container services work. So let's select the elastic container service. So here we can see it's a fully managed container and highly scalable and fast container. And also here we can see the pricing list. So Amazon ECS and AWS Fargate and EC2 and the Amazon EC2. So let's click the Fargate pricing. So here we can see the price overview. So it upfront cost and you pay only for the resources you use. And it's a pricing calculator. And the pricing. So here we can see the reason is US East and the per CPU per hour is a $0.04048, and you select the reason and you will see also. Asia Pacific Mumbai we are using, right? So here we can see. So per CPU it's a 0.4256. So per GB per hour. So based on the region and the CPU you use, you can pay for that. So here the pricing. So the pricing is based on the using the CPU and the using the memory, that is GB. So let's get back and here we can see. So Amazon ECS and Amazon ECS in. So you go inside this, you can see the pricing. It depends on the what service you use. So So let's go to the cluster. So here we can see here there is no cluster is created yet. So first we need to create the cluster. So give the cluster name. I will give as ECS app. Okay, right. So the next is infrastructure. Your cluster is automatically configured for AWS Fargate in serverless with two capacity provider, that is add Amazon EC2 instance. One is AWS Fargate, that is serverless. It's based on pay as you go. Use if you have tiny batch or burst workloads or zero maintenance overhead. The cluster has Fargate and the spot capacity provides by default. The another one is Amazon EC2 instance, that is manual configuration. So end to end in the EC2 we can do manually. So here I am using the Fargate by default and I will give the name ECS app and like this. So nothing to create or anything. Let's create the cluster. So here we can see it's in progress. So wait till it creates. So here we can see cluster ECS app has been created successfully. So refresh this. Here we can see the service is 0 and the task is no task running and the container instance is 0 EC2 and the CloudWatch is default, right? So here what it says, it's no task is running, means we are not creating any task. So if you go inside this, here we can see the ARN and the state is active and the task is running and running is nothing is running, right? So here also we can see there is no service and click here, the task is also no. So here what we need to do is we need to create the task definition. So let's create the task definition. So here we need to create a new task definition. So create new task definition. So here it asks for the task definition family. So it's a specify the unique task definition family name. So here also I am giving the same, that is ECS app. And the infrastructure requirements, here when we are creating the cluster, we will know how to create the infrastructure requirements. Here also I am choosing the AWS Fargate. It's a serverless compute for the resources. And the next thing is operating system architecture. Here we can see, so here we are using the Linux. So there are different options available for the Linux and the Windows server. So I am choosing the Linux x86-64 only. And the CPU is 1 with CPU and the memory 3 GB and the task role. So that's we not to create anything the same. So the next is container details. In the container details, it specify a name, container image, whether the container should be marked as essential. Each task definition must have at least one essential container. So here we need to give the container details first. So let's give the name. So for the name, what we need to do is go to the Chrome and you can check for Amazon ECR public gallery. So go, so open this. So here we need to search for the Nginx. So here we can see this is the Nginx. It's a official Nginx Docker images. It's an HTTP and reverse proxy server, a mail proxy server, and genetic TCP and UDP proxy server. So go inside this. So in the Nginx, here we can see this is the name, and here it get the URL of the image. So yeah, here we can see it, we can get the image URL, right? So copy this name and go to your container details. Here we need to give the name of the Nginx and copy the URL and go to the container details. Here we need to paste the URL. So first in the Chrome we need to open the Amazon ECR public gallery. In the search bar we need to open Nginx. Here we can get the URL of the image and name of the image. So we can copy and paste this. The next thing is, so we are give the URL and name. The next is the container port is 80 and the protocol is TCP, and the other thing is all default only. There is no need to change anything. So the next is click on the create. So here we can see the task definition is successfully created. It contains the task execution role and task size. So task CPU and the task memory. So the next thing is go to the cluster. So in the cluster we can see we are creating task definition, right? So click on refresh. There is no service, so go and to the task and refresh this. So here we can see, here we cannot see the task we are created. So first we go to the task definition. Here what we need to do is first we need to deploy the task. Later we will see in the cluster. So first deploy and create a services. So first we need to create the service. Yeah. So here we can see the cluster name is ECS app, and the compute option is capacity provider strategy. It's a take it as default, and the capacity provider also it's a Fargate, and the services. So here we can see the families ECS. So the name we are giving in the cluster and the task definition, it is the same as family. And the next is service name. So I will give as Nginx service. So we are creating the image as a Nginx, right? So that's why again the service name also Nginx services, and the desired task are 1, and the availability zone balancing service and then go to the networking. So here the VPC taken as a default and the subnet is taken for this VPC only. And the next thing is security group. So here we need to create a new security group. So give the security group name. So I will give the name as container security. So and give the security group definition. So it is giving us security group for Nginx container. Here also giving the name is container security group and the description as okay. The next thing is we need to add the inbound rule for the security group. So let's go to the type here. So go for the HTTP, select the HTTP, take the port range is 80. So the source is taken as anywhere, and there is no need to give anything. Click on create. So here we can see Nginx service deployment is in progress. It takes few minutes, so wait until it's created. So here we can see we can get the service name. So we have created the Nginx service, right? So here we can see the status is active and the deployment and the task. So it's in progress, and go to the task. So here we can see task is created. It's in the status of running. So go to the service and go inside this Nginx service. So here we can see the service overview. It contains the active states and task desired. So one is running, and it's a deployment state is in progress, and the status Nginx services. So here we can see the health. It contains the CPU utilization and the memory utilization. So it contains all the details of the services and task is created. So and go to the task. So here we can see the details of the task and the containers, and go to log. So here we can see the log details, timestamp and the messages, the task we are created, and it contains which container, and go to deployment. It's in progress, so it still take time to deployment, and go to events. So here we can see the February 3 it started, and the message it has started one task, and it contain event ID and the service auto scaling, configuration and networking. It contain all the details of the services we are created, and we are using the networking, which networking configuration, and the availability zones, like that. So it contain all the details. So here we can see the deployment. The Nginx services has deployed successfully. So go to the deployments, refresh this. So here we can see that last deployment, it contains the deployment ID, and the deployment status is success. So here we can see it's deployment is successful, right? So in the task, go inside this task. So here we can see it contains all the task overview, status and the configuration, right? So copy this public IP address, go to the Chrome and paste it here and open this. So here we can see. So it's welcome to the Nginx. If you see this page, the Nginx web service is successfully installed and working. So further configuration is required. So here when we are creating the task definition, we are giving the name as Nginx and giving the Nginx image URL, right? So when it's the Nginx service is successfully deployed, we can get the Nginx images. So this is how Elastic Container Registry work. So we all know that till now we all know how to create the images, use and the task definition and cluster, right? So just go after deploying success. So after deploying successfully, the Nginx services has been deployed successfully. Just copy the IP address of the task configuration and paste it in the Chrome, so we can get the Nginx image details. So this is how we create the Elastic Container Service. So the next is we will know how to delete those services. Just go to the cluster. So in the task configuration, here we can see it, right? So the first thing is we need to stop this task. So click on stop. So it successfully stopped the task. Refresh this one second. So here we can see desired status are stopped, right? So the next is go to the cluster. Here we need to delete the services. So select this Nginx service and delete the service. So click on force delete and give the name delete. So successfully deleted the Nginx service, right? So click on the services and go to task, refresh this. So desired status are stopped. So another one is running, right? Go inside this, stop. So it's stopped now. So in the ECS app, the services are deleted, and go to task. So task has been stopped. Okay, here we can see, yeah, task is stopped. So the next thing is we need to delete the entire cluster. So click on the delete cluster. So click on delete. So the service deletion, no service to delete, and container instance deregistration. So no container instance to deregister. And the next is cluster and stack deletion. So it takes a minute to delete this. So click on close. So here we can see it successfully delete the service and successfully stopped the task. Here we can see. So the created cluster ECS app is inactive. So this is how we need to create. So the next thing is go inside this task. So go to task definition, right? So here we can see, refresh this once. So here we can see it's in active status, right? So select this and go inside this. Here we need to select the app task definition app we are created. So select this and we need to deregister this. So it's successfully deregistered. Here we can refresh. So here we can see there is no task definition. So once we created, and when we are deleting the cluster, we need to deregister the task definition also. Otherwise the task is in running active status only till we need to deregister. So this is how we need to create the cluster task definition, and we can see how it works and how the images are created. So and also finally we will know how to delete the clusters task definition and how to deregister the task definitions. So this is how Elastic Container Registry work. Thank you.